can get started. Okay, and if any problem arises during the session, just let us know, and we can figure it out. So we can get started now. Good morning, everyone, or afternoon, or evening, night. It's morning for me. Wherever you are in the world, I hope that you're having a great time, and it's a pleasure to welcome you to the first speaker session of STEM Quest 2.0, which is the second edition of this global STEM speaker series led by Youth STEM Initiative and MedExplore. My name is Amirali. I'm the founder of Youth STEM Initiative and also the executive director. And in this session, I'll be talking about the emotional brain, particularly exploring this question of why our emotions so often get the best of us, why our decisions are so often governed by our emotions, which is typically not a great thing, but also how can we enhance our decision-making through cognition. So a bit about me. I am currently a neuroscience undergrad student at the University of Washington in Seattle. Just finished my first year last week. While I live in the States now, I grew up in Vancouver, Canada, which is a short ride across the border from Seattle, and originally I'm Persian Turkish. I love writing. You can check out my blog on Substack and also my ebooks on Kindle. Writing has always been one of my top passions, and I write every day, whether that be about science, neuroscience, or life experiences, whatever. I also love football, not American football, the real football. And I love playing the piano and going to concerts, hanging out with friends, meeting new people, trying new experiences and exploring the world, among like a million other things, but we need to move on. I started Youth STEM Initiative in August of 2023, so just under 2 years ago. And I'm really glad to see the amazing impact that it has had so far, with many more exciting things to come. Well, there's nothing that fascinates me quite like neuroscience, and I find myself constantly asking questions like, what the hell even is consciousness? Why do we make bad decisions all the time? Why do we sometimes feel things differently with the same set of neurons? Or again, why do our emotions get the best of us? And while studying neuroscience, writing about it, or even presenting it at sessions like here today at STEM Quest, I try inching closer to understanding these fascinating topics a bit more each time. And to begin with, let's examine what emotions are actually made of, so the components of emotions. These are just the basics, and to illustrate it, I have a situation, a frightening situation for you. So let's say you're in the woods, right? You're walking and you see a bear. Now, naturally, you'd probably start to feel nervous. After all, it presents a threat to your survival, and you suddenly begin to feel tense up, and you like become nervous, wondering what to do and how you're going to deal with this threat. This is what you call the subjective experience, or the behavioral response, should I say, of emotion. So in this case, this boy you see here, he is startled, and you feel nervous because you're afraid of this bear, and you feel like you have to take some kind of action or it will attack you. And when I mentioned tensing up before, I kind of gave a hint into another component of emotions, and that is the physiological response. So when you see this bear, your amygdala activates and your body goes into fight or flight mode, which you probably heard about in your biology class or whatever. Pumping adrenaline, which increases your heart rate and your breathing rate, and it constricts your blood vessels, makes your muscles contract, all to prepare you for action. And these are changes in the body that occur alongside emotions. And these physiological reactions don't just happen in response to being near a bear, but in really any emotionally charged situation. So you could feel it when you're stressed about anything, pretty much, like in a heated argument, or when you win a tournament, for instance, like the euphoria you have from that. And to talk more about this behavioral response of emotions, this component is what I like to call the phenotype of emotions, how emotions are actually expressed, and what you see on a person's face, for example, as a result of the emotions that they're experiencing. So in this case, you may look, like I said, startled or distressed at the sight of this bear, which is of course a natural reaction to anything that could pose a threat to your survival. And so, as you may have figured out by now, this is why we evolved to have emotions in the very first place. It's a defensive mechanism to keep us safe from threats. Now let's dive into some neuroanatomy. So emotions are primarily processed in the limbic system, which includes a series of interconnected structures deep inside the brain that work together to process emotions. And we'll begin with the amygdala, which is, first of all, don't judge the structure by its volume. It's very small, yes, the size of a pea. But the amygdala is saturated with neurotransmitter receptors with intricate synaptic connections, and these connections rapidly process external stimuli to respond to some of our most significant emotions, such as fear, anger, or even pleasure. Next is the hippocampus. Yeah, there we go. Which essentially serves as a link between emotions and memories. And the cool thing about it is that it helps us learn about past experiences. So we hopefully don't repeat some of our past mistakes. And when you think about your most vivid memories, those that you can remember like the most strongly, one thing that they all share in common is that they have a powerful emotional component to them, no matter how beautiful or ugly they are. This is how strong the link between emotion and memory is, and it is thanks to your hippocampus. Next is the prefrontal cortex, which is the rational thinker of the group, the mature one essentially. It plays the role of processing emotions in a logical manner while controlling impulses and decision making. And I say the prefrontal cortex is the mature one because it makes you take a step back, assess a situation critically, delay instant gratification, and make reasoned choices that prioritize more important long-term goals that you have over immediate emotional impulses. The next area is one you may have not heard about before and is less commonly studied. It's called the orbitofrontal cortex. This structure, which is located on the ventral surface of the prefrontal cortex, as you can see in this brain diagram, is like a secondary rational thinker that works together with the prefrontal cortex to evaluate and balance reward and punishment. In doing so, it helps us assess the emotional significance of a situation, and this is based on like past experiences, and it helps you decide how to behave appropriately in response to that situation, based on what's going on there, and also, again, what you've experienced previously. Moving on, we encounter the ventral tegmental area, or the VTA. So this is a small but smart region that's located in the midbrain, and it assigns emotional value to experiences, reinforcing pleasure by seeking reward while avoiding harm, essentially. And how does it do this? Well, it does it with dopamine, because the VTA is part of the dopaminergic system of the brain, sending dopamine signals to different areas of the limbic system to promote reward-seeking behavior and also emotional learning. Finally, we have the hypothalamus, and you probably know this structure as the governor of the endocrine system, or as you're about to learn, it's the portal between emotion and physiological response. Now, the hypothalamus is unique because it isn't just a relay center between emotional input and physiological output, but it is also able to make sense of the input and regulate the appropriate hormonal response from that input. Essentially, the hypothalamus tries to determine what emotions you're feeling and secretes the hormones that are needed to be secreted in response to them. It's important to understand that the limbic system and prefrontal cortex are interconnected and interdependent, which means that they both influence each other and are dependent on each other as well. For instance, like the limbic system affects cognition just as the prefrontal cortex affects emotional processing and regulation. Now, moving on to the theories of emotion. So obviously emotions exist for a reason, just as anything else, or really it exists for multiple reasons. And due to their complexity and their immense changes from time to time across a variety of contexts, neuroscientists and psychologists throughout history have proposed dozens of theories to attempt to explain why and how they occur. Now, there are tons of theories and we don't have time to explore all of them, but these are the 5 most influential ones that are worth knowing about. Number 1 is Darwin's theory of emotion. So the first one here talks about Darwin. And as you probably know, it involves evolution. So of course, evolution is a key aspect of this theory. Emotion, according to Darwin, evolved as a survival mechanism to direct prompt reactions to environmental threats. And this mechanism is directed by the amygdala, which we just covered right now. It basically identifies threats and triggers the fight or flight response through the sympathetic nervous system. What's more fascinating are the mirror neurons in our premotor cortex, which have evolved to aid in social bonding behaviors by helping us identify and mimic the emotions of others, which is something you can observe especially in children. The biological hardwiring of our emotions can be best exemplified by the cultural universality of our facial expressions, which is a key element of our evolution that basically knows no bounds and transcends geographic regions and generations. The next theory is the James Lange theory. So James and Lange think that emotions arise from the interpretation of physiological cues after the physiological changes have essentially taken place. So bodily reactions are triggered by the autonomic nervous system, or the ANS, while the brain's primary somatosensory cortex, known as S1, and insula help process and interpret these internal sensations as emotions. Here's an example, which you can kind of see in the slideshow here. Let's say there's an angry dog that's barking at you. In response, as a physiological reaction, your heart rate instantly increases by command of the amygdala. And then the insula and S1, the primary somatosensory cortex in the brain, they do some math and detect a difference in your heart rates before and after the stimulus. And they interpret this as fear. But this theory might not be the best. There's a caveat. Studies have been done on people who have spinal cord injuries. And because of their spinal cord injuries, they lack physiological feedback due to damaged spinal nerves. And these studies have actually contradicted this theory because they're still able to feel emotions despite spinal cord damage, which plays a huge role in physiology. So, I mean, it looks like it didn't take a lot to undermine this theory. Anyway, moving on. We have the Cannon-Bard theory. So Cannon and Bard have a different idea, and this is that emotions and physiological reactions tend to occur together, not one after the other. The thalamus simultaneously relays signals to the hypothalamus and the autonomic nervous system for physiological reactions, and also the brain for basically emotional conscious awareness. This theory actually explains why people with impaired bodily reactions, like those with spinal cord injuries, can experience feelings regardless of the physiology, which is obviously something that the James Lange theory failed to address. The fourth one is the two-factor attractor theory. So they propose that the emotions we experience result as a combination of cognitive interpretation and physiological arousal. Arousal is produced by the limbic system and also by amygdala activity, while the hippocampus and prefrontal cortex help in situational assessment. Our perception of our own physiological sensations is crucial in the processing of our emotions. So like our heart races when we swoosh down a roller coaster, let's say. And we may categorize this as exhilaration and joy. So But if the same roller coaster becomes, shaky and bumpy, then we might instead categorize our emotions as fear, which um, which is interesting because the physiological response is still the same. It's just a racing heart. So this points to the fact that adrenaline alone doesn't produce our emotions. It is simply a hormone that excites many aspects of our physiology. So again, interpretation and context are absolutely fundamental in how we experience our emotions. Finally, I know this is a very long slide, so stick with me on this, is the theory of cognitive appraisal by Lazarus. So according to psychologist Richard Lazarus, our thoughts influence our feelings, which is why we tend to assess a situation before we actually feel it. This is what cognitive appraisal is all about. It's about evaluating the emotional significance of a scenario and coming up with an appropriate response for it. And when it comes to evaluating events and determining the appropriate emotional response to them, again, the prefrontal cortex plays a big role. When you see a shadow in the dark, for instance, your brain will do one of two things. It will either interpret the shadow as a threat, which makes you fearful, or rather interpret it as something harmful, a threat to your survival, or you may interpret it as something that is innocuous. So like it has no harm, it doesn't present any threats, which makes you feel relieved. This again speaks to how important cognition is in the prefrontal cortex, to make sense of our emotions and the situations that we face, and also to regulate the emotions that we express as we make decisions on how to appropriately behave and respond to something. Just gonna take a 2-second break and drink some water before moving on to the next slide. All right, don't worry, that was our longest slide. The next ones won't take that long. Well, now the question that's basically forms the basis of this presentation: why do our emotions get the best of us? And the answer to this lies in neuroprocessing speed. So our emotions so often get the best of us because they're driven, as we learned, by the limbic system, and especially the amygdala, which processes information very quickly. In fact, too quick for the prefrontal cortex to keep up. In other words, it processes emotional stimuli faster than the prefrontal cortex can regulate them and reason them out. Because of this, in high stress situations, with high emotional content, like a moment of intense fear or exhilaration, an immediate emotional reaction is triggered by the amygdala before the logical reasoning from the prefrontal cortex kicks in. And dopamine and serotonin play crucial roles in modulating emotional intensity. As you may know, these two neurotransmitters are among the most influential and commonly secreted in the brain, which explains why some of our emotions, such as enthusiasm and grief, can often feel so powerful and, in a sense, difficult to control. And in the underdeveloped brain in particular, such as those of teenagers, it is difficult for the prefrontal cortex, which again is responsible for impulse control and decision-making, to regulate these emotions and have logical thinking take over. I mean, it's no surprise that this is the case considering some of the questionable behaviors and decisions made by people in this age group, but they learn eventually. Now, of course, you can't avoid emotions. You can't just shut off your limbic system or your amygdala. That's just not possible. They'll always be there because they're important. They're there to literally save your life, or at least they're wired to do so. And you need them as a result. But what you can do is train your prefrontal cortex to enhance your logical thinking and cognitive processing to strike a better balance between reacting with thought versus reacting emotionally to every situation. I'll talk about how you can do this more afterwards, by the way, towards the end of our presentation. But we cannot blame ourselves for being so emotional. After all, evolutionary speaking, our limbic system and its emotional processing mechanisms have had more time to develop and evolve than our prefrontal cortex, for instance. as it's a more primitive function that's guided more towards our survival. So our emotions and intuitions play huge roles in our decision making that we can't simply ignore. We inevitably experience their effects. Now, here's the difference between the prefrontal cortex and the limbic system. So as you can see, the prefrontal cortex processes information slowly. It is rational and deliberate, driven by purpose and logic. Whereas the limbic system, it's fast, it's emotional, obviously, it's instinctive, and it is driven by reaction. So not much thought, just instinctive reaction. So hopefully this graphic kind of highlights the differences between them. And this is a book that you've probably seen, especially if you've taken psychology courses. But regardless, to better understand why our emotions get the better of us, I suggest reading Daniel Kahneman's Thinking Fast and Slow. So in his book, he debates this idea that humans are purely rational beings and argues that our decisions and thoughts are often dominated heavily by our emotions and intuition, which is what he calls fast thinking, which is system 1, over slow thinking, system 2, which is the more deliberate, logical thinking done mainly by the prefrontal cortex. That's slower and demands more mental energy, but that ultimately leads to much better outcomes, especially in the long term. Again, it's all about processing speed, because our emotions beat out cognition in this respect. We may behave in a particular way in the heat of a stressful moment that we later regret, or we may react without fully considering the outcomes of our decisions. Emotions are just so incredibly hardwired into our brains. It's almost impossible to entirely avoid their powerful effects on our thinking, decision-making, and generally our behavior. And again, as Darwin postulated, we have them for a reason, right? They're there to save us. And considering our evolutionary past, where fast thinking was a lot more significant, keeping us from being eaten alive and reacting in time, it does make sense that we've had so much more time to develop this thinking system over slow thinking done by the prefrontal cortex. But regardless, as I promised, there are many ways that we can regulate our emotions better and think more logically. And here are a few that I have for you today. One is to practice deep breathing and meditation. This will help you relax your mind and your body, make it less reactive and more calm. And with a calm mind and body, this will take you a long way, because it will help you react less emotionally to situations and more with thoughts. You'll take a step back when you're facing something difficult, a stressful, intense situation. You'll actually think about it critically and then make a decision, rather than just react emotionally and instinctively, which will probably not have the best outcome. So deep breathing and meditation is crucial. Next, practice critical thinking. And much of this comes with experience solving problems, or even debating and embracing other people's perspectives and trying to figure out why people think the way they do, and why they do things the way they do. So, and it's not just other people, but more importantly, yourself. Critically, sometimes just like sit down and think about how you would react to certain situations and why you would react that way. This will help you achieve more clarity in your thoughts and ultimately help you respond better to situations. Once again, critical thinking is key. And my third tip is to journal. Brain dump your thoughts and feelings onto a notebook, preferably a physical one. So handwrite all of this. And this, based on personal experience and also from a ton of research, has been proven to be one of the most effective ways to understand yourself better. And also it provides a safe place and space to explore and express your emotions better, so that when you face emotionally charged situations, you can handle them with ease. So I'll leave you with this and encourage you to note it down and put it up on your wall or whatever. As much as the modern world is fast-paced, thinking slower and more deliberately while controlling our emotions can take us a long way. Believe me, this is an important skill to have, and it lies in the intricacies of your beautiful brain and nervous system. So you have the neurons, now you have to train them to work better together, and especially your prefrontal cortex to help you think more logically before making decisions. Well, that concludes my presentation. Thank you so much for listening. And now it's Q&A time. So if you have any questions, feel free to just speak up or put it in the chat, and I'll be happy to answer them. Haley, do emotions affect how you sleep? As far as I know, yes, it could affect how you sleep. Obviously, for instance, when you're feeling very happy, or it could lead to excitement, and as I said before, emotions doesn't have to be just like when you're happy or excited. It's also when you're stressed, for instance. It often leads to the pumping of adrenaline, and when you have a lot of adrenaline, well, you won't be able to sleep properly. Your body is not calm, and as a result, this could affect your sleep, which is why, again, things like meditation is so important, because if you're very emotionally charged and you're always reacting to stuff, your body's always producing adrenaline to everything. This is not good for your long-term health, because it's not just adrenaline, it's also cortisol, which can have effects, and this can altogether affect your sleep, and you won't sleep, as deeply or as efficiently as you would if you were calm. So it definitely has an effect, but as long as you can regulate your emotions, then that's actually one of the keys to having healthy sleep patterns and being able to sleep deeply. Is there a correlation between neuroplasticity and emotions? Do emotions enhance neuroplasticity? This is not something I've researched, but I'm sure that there is, because, well, emotions, they're very hardwired into our brain, but depending on situations that we may face throughout life, and how much of an emotional content there is to those situations, there will be some neuroplasticity that happens naturally, just as with a lot of other processes in the brain. And as I mentioned before, one of the key components to some of your most vivid memories are emotion. And when there's a lot of emotion that is involved in a particular moment, that will strengthen that memory, which is, of course, done through neuroplasticity. So yes, as far as I know, there is a correlation between neuroplasticity and emotions, and it really differs from person to person. Is there a difference between the neuroprocessing speed of men and women? I'm not sure about that one. I could imagine there might be like a small difference, but just because the brains of males and females are wired slightly differently in some ways, so there must be a difference. But yeah, that's an interesting thing to research. And yeah, but I don't have a definitive answer for that. How are some emotions stronger than others? Well, again, this comes down to the hormones that are produced, and also just how fearful a situation is. So, like I said, in a situation where, let's say, you see a bear, right? That is something that will produce a very strong emotional reaction. And that's because your amygdala sees that more of a threat than, let's say, I don't know, a spider you might see that's like in the distance. It sees that as more as a threat, and as a result, there's more adrenaline that is pumped, and your body begins to like tense up, and all those physiological reactions I talked about, they happen more quickly and more intensely. So it really comes down to the hormones that are produced, which may make some emotions stronger than others. And of course, that depends on what kind of situation you're in, and, you know, whether, again, it's a bear that's next to you or like a spider that might be harmless and might do nothing. Next question. Are there any studies on how people with hyperphantasia, a highly vivid visual imagination, perceive and feel emotions? I'm not sure, actually. That's a very good question. Yeah, I honestly won't know about whether that has an effect. But yeah, it's a great area for research, and I might save this to research it myself later, actually. All right, this one. When I think about the topic, why emotions get the best of us, I can't help but relate it with the Cyber's concept of liberty. There are two types of liberty, positive and negative. When we talk positive liberty, it is us making decisions by our own, acting in accordance with others, and negative liberty is when there are no constraints holding one back. So basically, emotions getting the best of us means we are losing the positive liberty of making decisions rationally. Yeah, right. Yeah, that's an interesting point. I haven't heard of this actually, this concept of liberty. You have to think about that. But yeah, I mean, when it comes to our emotions, based on what I know, I mean, usually it's not guided by something that is inherently bad. We don't have bad intentions when we react emotionally to something. It's just, again, a natural response of our body to a particular situation. And again, we've been evolutionarily wired to do so. But yeah, I guess my thought is that I do agree with the statement of when your emotions get the best of you, it means that you are losing the positive liberty of making decisions rationally. I do see where that comes from. Which again, this is why it's so important to regulate your emotions, to prioritize critical thinking, train your prefrontal cortex to think through things critically and logically. Because after all, it's not about, I guess, how badly we react to something or how well we react to something, but how we are able to deal with situations in a way that, first of all, doesn't harm ourselves or others, and is also beneficial. It kind of brings some benefits in terms of how you can deal with situations like that in the future. Because again, a lot of the decisions you make, they can have long-term impacts. And if you can learn to regulate your thoughts better, then in the long term, that will benefit you in a lot of ways. But yeah, that's something that I'd like to look into more, this concept of liberty. So thank you so much for sharing it. Why do we sometimes react emotionally before thinking logically? Again, this is about neural processing speed. So your amygdala, your limbic system, it fires first. It processes information first, just naturally. So because of this neural processing speed that the prefrontal cortex cannot keep up with, that is why we first tend to react emotionally, and then afterwards we kind of, get some mental clarity, and you start to think about it logically, and that's why regrets, for instance, after you do something, comes after, because